Now, this is video number 21, example 2. I read the question. 4 forces, F1, 2I minus 5J, F2 is equal to SI plus YJ. F3 is equal to 7I plus 3J, and F4 is equal to minus 6I plus J. Act on a particle. If this particle is at equilibrium, find the values of x and y. Find the values of x and y. Solution. Solution. Now we are told that these 4 forces are acting on the particle and that the particle is at equilibrium. So if the particle is at equilibrium, then summation f sub I is equal to 0. Summation f sub I is equal to 0. Why? Why? For equilibrium. For equilibrium. So let me explain here. That when forces are given in vector form, in this case ij notation, you don't need to find the horizontal component or find the vertical component again. Just add the forces direct and equate it to 0. That is the procedure. So that is that. So since the forces are given in ij notation form, then we simply add all the forces, all the given forces, and equate the sum to 0. Since they have equilibrium, since they are at equilibrium, that is F1 plus F2 plus F3 plus F4 is equal to 0. So this implies that, and what is F1? What is F1 here? 2I minus 5J plus SI plus YJ plus 7I plus 7J plus minus 6I plus J. This is equals to 0. That is what I'm saying. Equals to 0. That is for equilibrium. So at this stage, we now equate the corresponding component. So we equate the sum of the I component to 0. Now I have 2I plus xi plus 7i minus 6i is equals to 0. That is equating the I component to 0. That is by equating the sum of the I component, to 0. So this means that 2i plus 7i is 9i. 9i plus 6i is 3i. So this means 3i plus xi is equals to 0. Dividing throughout by I have 3 plus x is equals to 0. Therefore, x equals minus 3. So, got the value for x. I think I can do this section. Is this not the question?
Yes.
Okay, you'll be able to read it for me, but.
Yeah.
Okay, is it?
No, I'll not be able to read it.
Okay, no problem. So now we are on B part. B part of the question. B part of the question. I read the B part that forces of magnitude 3 Newton, 5 Newton, and 7 Newton acting on a particle are at equilibrium. Find the angle between the forces of 3 Newton and 7 Newton. In this case, we can use Lami's theorem here. So all I have to do now, it means we have a particle at a point. So let me show you the first diagram of this question. We have a particle here. This particle. I'm using that point to represent the particle of the body. And this particle is subjected to these 3 forces, 3 Newton, 5 Newton, and 7 Newton. So we have, this is 3 Newton force, Then you have, the next force is 5 Newton. The next force is 5 Newton. Going that way, this is still that particle there, to be subjected to the 3 forces. So this is 5 Newton force. Then we have the third force. We have the third force. Which is so. This is the first diagram of that question. That is the first diagram of that question. So the question now is, we should find the angle between the 3 Newton and 7 Newton. The angle required is this angle. Let it be theta degree. We have to find that. That's what the question is asking for. We should find that angle. Now, we should find that angle. So, now, let this one be alpha, and let this one be beta. Let that angle be beta. Let that angle be beta. So, now, how do we find the angle between that? We can represent this. We can draw the triangle of forces for this. I can clear the question. Here, I can transform this into a triangle of forces. how do I go? Here, I go like this. I go like this. Draw one side of the triangle parallel to that 5 Newton force. To that 5 Newton force. So, this is that 5 Newton force. Then this one that is vertically downward, I draw it. Vertically downward, I draw it. Or, now, this one is going this way, so I show the arrow first. I show the arrow first. So, now, from the head, now this is the tail of this vector, this is the head. From the head of this vector, I draw another one. From the head of this first one that I have drawn, I draw the second first. Parallel to that, yes. So, I have that. This is that 3 Newton in that direction. To the 3 Newton force. I can produce it. Produce it like that. Then 3 Newton force, not by measurement. Now, again, this is the head. This is the head of this very second vector. From the head, I draw the third force, which is vector. Also, parallel to that. Now, I can find my polygon of vector was closed, and then this is it. Yes, this is my triangle of vectors. This is the 7 Newton force. So I have my triangle of forces. My triangle of forces. This is 5 Newton force. Now, what I'm to do now is to. So what is the question asking? The question is asking, that means I can either use Lami's theorem or I use the law of triangle of vectors, which here is going to be simpler for me because I don't know any of the angle. So Lami's theorem may not easily be visible. So since I know all the three sides, I can quickly, I just go direct and find the angle between the 3 and 7, I think, yes, 3 and 7. The angle between this 3 and 7 Newton force, so I can find it. Now, if I find this angle, maybe call it lambda. If I call that, now since because this is going this way, so that the angle that is actually required here is this angle theta. Degree. That's what I'm looking for. You can see. That angle theta degree. So the first way to find this is to find this theta. I mean that angle lambda. So here I can apply my cosine rule. Since the three sides of the triangle are done. Applying cosine rule. to the triangle. I have uh, 5 square. 5 square is equal to 3 square plus 7 square minus 2 into 3 into 7 cos lambda. Apply cosine rule. So this means that 25 is equals to 9 plus 49 minus 21 times 2, that is 42 cos lambda. 25 is equals to 9 plus 49. That should be 58. 58 minus 42 cos lambda. Now, take this 42 cos lambda across and 25 across. So I'm going to have 42 cos lambda is equals to 58 minus 25. So now 58 minus 25. 42 cos lambda equals to 58 minus 25.
33.
33. Is equals to 33. Therefore, cos lambda is equals to 33 over 42.
0.7857.
Cos lambda is equals to
0.7857.
7857.
Yes.
Therefore, lambda now will be cos inverse of 0.7857.
Which is equal to 38.21.
38.21 degree. Therefore, theta is equals to 180 minus 38.21 degree. 180 minus that.
Minus 38.21 is equal to. I'm sorry. 180.
180 minus 38.21
is equal to 141.79.
141.79. Okay. So theta is approximately equals to 142 degree. That is my answer. Done. That is the angle between 3 Newton force and 7 Newton force. I think I have explained it.